In my previous video, we have seen the intercommunication between microservices using synchronous and asynchronous approach, right? Now let's see the implementation for each of these things. So when user wants to do a booking in the flight booking system, a request is sent to the booking service and the booking service will send a request to the flight service, and here we will create this method called as reserve seat in the flight service and create booking method in the booking service. In my previous video, I have shown you in booking services how to use the seal classes. But to continue with my rest of the series, where I already have developed some videos which are related to distributed tracing and the circuit breaker, I have given a simple example using the reserve seat. So I will be implementing the same functionality now in booking service. So in synchronous communication, service A is communicating with service B and waiting for the response. For synchronous communication between microservices, we can implement it using various approaches such as RestTemplate, Web Client, Feign Client, and HTTP Exchange. We will see all of this thing very soon. First, we will cover using the Feign Client. Feign Client. So Feign Client is a declarative web service client in Spring Boot that simplifies the process of making HTTP requests to other services. It is designed to reduce the boilerplate code and it allows you to define the HTTP client using interfaces and annotations. You can see more information in Spring Cloud OpenFeign website. So here if you can see, it has dependency on Spring Cloud OpenFeign and it will provide the detailed information about the declarative approach and how we can use it. We need to do some configuration enable for this thing. I hope you remember this booking controller class, right? So inside this booking controller, previously we have seen the flight booking service and hotel booking service. Now we will create one more instance of booking service and we will create one controller for the same called as create booking. So this create booking will call the booking service instance and it will reserve the seats. Now let's see how we have defined this booking service. So for this booking service, inside the service module, we will see this interface, booking service. Here we are defining this method called as reserve seat. Don't get confused with the create booking method. This create booking method we have used for flight booking and hotel booking. Now for calling the flight service, we are using the reserve seats method as we are showing in our picture also. So this reserve seat method will call the booking request method. The booking request class is available in the model package. So go here inside the booking request. As you can see, previously we have some information. I have added two more information here. The private string flight number and private int seats. These two we need for the reserve seat functionality. We will define booking service IMPL to implement this reserve seat method. But before going to this reserve seat method, let me tell you some more information about the flight microservices. I hope you remember in my previous module I have shown you how to develop the flight services, right? The flight microservices is not currently having this functionality called as reserve seats. So let's first implement this reserve seats functionality in flight microservices and then we will come back to this method and we will see how we can use the flight services inside the booking service. Let's go back to the flight service, and inside the flight service we can define this reserve seat method inside the flight controller. So for this thing, first we will provide a put mapping, because what we want inside the reserve seat functionality is like whenever user is booking any flight, so it will provide some information like for which flight he want to do the bookings. So bookings means number of seats, how many he want to reserve for a specific passengers when he is doing the booking. It can be a passenger, it can be any other user, or it can be third party agent. So for our information and for our easy step to implement, what we are doing is here we are defining the reserve seat method, which will take two parameters. The first parameter is the flight number and the second parameter is seats. So what this will do here, it will first try to find out this flight information. If the flight is available, then it will check for the seat availability. If seat is available, then reserve the seats. So we have used the put mapping, and inside the put mapping we have defined this path variable called as reserve seats, and it will use this path variable as id. And this id, as we are using the short form, I have defined this id inside the path variable, and later we can give any other name to refer. And then we are also using the request param where we are providing the seats information. Then this one is invoking the flight service. So let's quickly see how we have developed the flight service. So for the flight service, we have defined this method called as reserve seats, which will take this two parameters and it will not return anything. And inside this flight service IMPL, if we will go, we will see this method. So we have defined this method as a transactional. Transactional means it will go in the same request. Then we have defined this reserve seats method. So this reserve seats method, first we are printing the log reserve seats for flight number, and then we are calling the flight repository to find by flight number. And we will quickly see how we have defined this find by flight number method. So inside the flight repository, if you see, we have defined this method called as find by flight number. This find by flight number method will take the flight number as a parameter and it will return the flight object, which is optional. So let's go back to our flight service IMPL class. Here first what we will do, we will first find from the database that this flight is existing or not. If this find by flight number method is available, we will able to proceed. Otherwise we will throw this exception called as flight service custom exception, which will give us a message flight with given id not found, and we can send the error code as flight not found. Okay, now assume we found the flight number. So what we will do as a next step, we will try to find out from this flight object, give us the total seats, how many seats are available for this flights, and we will check if the total available seats is, let's say, less than what the seats we are requesting. Let's say we have 256 and we are requesting for 4 seats, then we are good enough. And let's say now the flight is in high demand and all the seats are reserved, only we have two seats, but the user has requested for 4 seats. So in such scenario this condition will not satisfy, so it will give us a message called as flight does not have sufficient seats, and we will throw the error code as insufficient seats. Now let's say we are good, we have the enough seats in the flights. So what it will do, then we will set the total seats, which will be the subtraction of this total seats minus seats. So it will reserve the seats for the specific passenger, and we will call flight repository dot save method, and this will save the flights. So this is how we will update the flight seats detail in the flight repository. Now let's run this application and we will see how the reserve seat functionality is working. For that thing, first we will see the application.properties file. Inside the application.properties file, we can see server port is configured for 8082. Now let's run this application. So here we can see the message started flight server applications successfully, right? And if we navigate further, we can see here the Tomcat is started on port number 8082. Now we will see the SQL. Okay, inside the SQL, if we run this query, here we can see currently there are total 220 seats available and total available seats are also 250. So once we run this API from the Postman, we will see the total seats quantity will be reduced. Now let's run this in Postman. So inside this Postman, we have configured this as a put mapping, and here we have defined the endpoint URL. Let's quickly see this endpoint URL in the flight controller. So inside the flight controller, if we see, we have provided the request mapping as /v1 API flights /v1 API flight, and then the method. So inside this method, we are using the put mapping with reserve seats. So we have added reserve seats and then the path variable. So the path variable we can give the example as EK402 as we have seen, and the number of quantity of seats. So we want to reduce, let's say, 3 quantity. So I have given the quantity parameter as 3. And also we can cross confirm the port number. So if we see application.properties file, here the port number is 8082. So this thing we are good to go. Now let's click on the send button. And here we can see the message successfully as 200 OK. So if we go to the SQL and we will run this query, here we can see the quantity has been reduced by 3. Initially it was 250, now it became 247. Similarly, we can go to the logs and we can see reserved seats 3 for flight number. So 3 seats are reserved and flight seat details are updated successfully.
Now we understood how to reserve the seats in the flight microservices, right? Now let's move back to our booking service. So inside this booking service, let's go back to our example called as booking service IMPL. So inside this booking service IMPL, so to understand this functionality about the booking services, first we need to define a mechanism how we will do the synchronous communication, right? As we are using the synchronous communication, it means we have to make our flight services up and running, we have to make our booking services up and running, right? But what we have seen in the booking services that we were running this on default port called as 8080. Booking service also is running on 8080, right? So this will clash if we start both the services together. So now let's see how we can overcome this issue. Let's define unique port in each of the microservices. So first we will go to the booking service, and inside the resources we have application.properties file. Inside the application.property file we will define server.port. We will start with 8081 and then we will see our flight service. So for the flight service we will define the port as 8082. And for the flight search service also we will define the unique port. This is 8089. We can define any of the port number, but you have to be very careful and you should remember all the port numbers. Once we have defined the server port, let's go back to our booking service example. So what we will do here, we will first define one external entity, okay, and we want to use the OpenFeign client, right? So for this OpenFeign client we have to define this in pom.xml file. So this is the dependency we have to use. This is coming from the Spring Framework Cloud and we have to use this dependency called as Spring Cloud Starter OpenFeign. If you remember previously we were using all the org.springframework.boot dependency, right? We have to choose Java as a language and Maven as a project, right? And in the Spring Boot, if you see now the latest version is 3.15, but we are still using the 3.0 version. So here you can add the dependency called as OpenFeign. And inside this OpenFeign you can see this is a declarative REST client. OpenFeign creates a dynamic implementation of interface decorated with JAX-RS. Okay, so click on this one, and if you explore here you can see the dependency for this file, right? So we have to add this section called as dependency management. This dependency management will use the org.springframework cloud and with some specific version. So this version is defined here, Spring Cloud version, and along with that we have to add this dependency. This dependency is from the cloud utility. So org Spring Framework Cloud, and we have to use Spring Cloud Starter OpenFeign. If you remember previously we were using all the dependencies from boot, org Spring Framework boot, and org, Spring Framework, Web, etc. Now let's close this thing. And in the pom.xml file, define the same dependency what I have shown you and the dependency management. Okay, and here the Spring Cloud version I was using previously 2020.0.2, but recent we have seen as 4. The next step is inside the booking service application, we have to tell the booking service application, hey, I want to use the Feign client. So we have to add this annotation called as enable Feign client. Next we will define one extra package. That package name is external. Okay, so inside this external package we will define one client, and this client is a flight service. So we will be defining one interface called as flight service, and inside the flight service we will use the same method what we have defined in our flight controller. So you can go to the flight controller class and copy the same method name. Okay, here we have to define this method signature. We don't have to use open and close curly bracket, but we have to use till this point. Okay, so copy this entire thing here and go back to the flight service and put this same thing here. Okay, this is step number 1. Then step number 2 is we have to provide the annotation called as Feign client, and inside the Feign client we have to provide two value. The first value is the name parameter, which you can give the name. As we are using this as a flight service, so we will give the name as flight service and the URL. So this URL is the endpoint URL to call this API. So what is the API for this one? If you go to the flight controller, here if you can see, we are defining this API request mapping, right? /v1/API/flights. So this is the same one, /v1/API/flights. Along with that, the localhost to call this URL. And if you remember here, we have defined this flight service on port number 8082. So if you go here inside the resources, we can cross confirm it. So for this flight service, we have given the name as 8082. Now let's go back to our class again, and inside the external client, once we have defined this Feign client, we are also defining one default method here. As you already know that from Java 8 onwards, we can define inside the interface a body parameter, right? Previously we have seen inside the interface we only have a declarative approach, but with the default usage we can define our own method and which will throw some exception, or we can print some statement, right? So here we will define this method called as fallback, which will throw this exception. We will see this usage of method inside the circuit breaker. So for Feign client, only this method is important. So for this reserve seat method, let's see how we are implementing this thing. So first we have added a log creating booking for this user. We got the passenger name here, and then we will first create the booking object using the builder pattern, and we will initialize all the fields from this booking request. So first is the passenger name, flight number, number of seats, booking number. This booking number is a unique ID. So this unique booking reference we will be creating using uuid.randomuuid.toString method. Then we will configure the amount, payment mode, and the status. As it is the first time, we will define the status as booking created. Once everything is completed, then we will modify the status back. Okay. It may happen that once we are invoking this flight service, it may throw some exception. So let's define some of the error code for this thing. So we will define one package called as decoder, and inside the decoder we will define the custom error decoder, which will implement this error decoder. And inside this error decoder method, we will call one decode method class.
Now let's configure this Feign config class. This Feign config class is annotated with @configuration, which indicates that it contains the configuration method that should be processed by Spring Container. The method ErrorDecoder is annotated with bean annotation, which indicate that it produces a bean. It returns an instance of ErrorDecoder, and especially it returns an instance of custom ErrorDecoder. This suggests that the application is using a custom ErrorDecoder for handling errors that occur during the Feign client communication. Now let's define this custom error decoder class. We can define this class inside the package decoder, and the main function for this custom error decoder is that it is an implementation of Feign error decoder interface. And the main purpose for this class is to provide the custom logic for decoding Feign client errors into the application specific exception. So first, this class is annotated with SL4J annotation, which will indicate that we will have a logged field name log, and it also implements the error decoder interface. Next, we have defined the decode method. This method is required to be implemented as part of error decoder interface. It takes the method key, which we are not using in our implementation, and there is a Feign response object, which we are taking as a parameter and returning the exception object. Inside this method, it logs the URL and a header for the fail request. It uses an object mapper to deserialize the error response from the externalized service. Very soon we will see what is the error response class. And then it will create and return the booking exception using the information from error response and the HTTP status code from the original response. If there is an IO exception during this deserialization process, it catches this exception and throws the booking exception with the default error message and the status code. We will define this error response class inside the response package, which we are defining as part of external package. And this class is annotated with Lombok annotation as mentioned here. These annotations collectively reduce the amount of code that needs to be written manually for this class. The first property is error message. It represents the error message associated with the error response. And the next one is error code, which represents the error code associated with the error response. These fields we have keep it private, means they can only be accessible within the error response class.
Now let's save this booking inside the booking repository. Once we have saved this thing, then we are just logging the status. After that, here we are calling the flight service, right? You remember we have defined this flight service as an interface. So once we define this interface, we have to call here using the auto wire. So here we have defined the flight service, and we will simply invoke the way we are using another repository or services. So we will call flight service dot reserve seat, and here we will pass the same two parameters, the flight number and the seats, and it will call the flight service microservices. And once it is calling this thing, we will say seats are reserved for the booking, okay, and we will print this message, and booking ID is created successfully.
We will quickly revise what we have done to implement the OpenFeign functionality to communicate from one service to another. As part of this, first what we have done, we have went into the pom.xml file, and here we have defined some dependencies. For example, the dependencies are related to OpenFeign. So we have added this dependency OpenFeign. As this is dependency is from the cloud utility, so we have to add one extra dependency management. And we have added this dependency management with this specific cloud version. So this cloud version we have defined on the top. Okay, this was our step number 1. Then step number 2 is we will go to the booking service application, and we will tell this application that we want to use the enable Feign client. Once we have done this annotation, then we have to create the interface for our application. So we want to use the interface for flight booking. So we have created a package called as external, and here we have defined this interface called as flight service. So this flight service is an interface and it will take the exact method signature what we have defined in the flight service. And also we have to annotate this interface with Feign Client with two parameters, the name and the URL. The name is the flight service and the URL is the localhost 8082 and the exact location what we have given in our flight controller. Then step number 3 is to handle any exceptions which occurs once there is a communication between booking service and flight service. We have implemented custom error decoder and the error response class. Along with that, we have used the booking controller now. Inside the booking controller, we have defined one URL mapping called as post mapping, which will do the create booking. And inside this create booking, we are calling the booking service. And we have created a new interface called as booking service and booking service IMPL. So if we navigate inside this reserve sheet, we are calling this booking service, right? So if we quickly go to the booking service IMPL class, here we have written the logic to reserve the suite. So we are calling the booking request, and this booking request we want to persist in the database, right? So what we are doing, first we are creating a model of booking object from this booking request with some additional informations which are there in the booking request. Along with that, we want to create a unique number, right? So this booking number we are creating using a unique uuid.randomuid method. And then we are saving this into the booking repository. Once this information is saved, we are first creating this status as booking created. And then we are invoking this call to call the flight service. And for invoking this flight service, we have to do the simpler way how we are using the other repository. We have to just use the auto wire and we have to provide this interface name. And then we will invoke this method. So this is how we will able to call from the booking service the flight service communication.
Now our code is ready. Let's start running the application. So we will go to the flight service application and we will run the server. You can note that discovery server I have started. I will cover in my next video what is discovery server and why it is required. The flight server is up and running. Now let's move on to the another thing. If you notice here, if you go top and search for the port number 8082, you can see here the Tomcat has started on port number 8082, what we have mentioned in our application.property files. We will now start the booking server. Let's run this application. And you can see here it is running on port number 8081. So if you see this has started in 24 seconds, and if we search here for 8081, you can see that it is updating this information on port number 8081. Now let's see the booking controller. Inside the booking controller, we have defined this request mapping, right? So how we will use this in the Postman? First, we have to use this 8081 port number and this followed by this mapping. And also we have to see if in the create booking we have added any extra URL endpoint. So we have not added any extra URL endpoint. So this one only will act as our URL endpoint. Along with that, we are using some request body, right? So request body is the booking request. So for this booking request, we have defined the 5 parameter. The first parameter is the passenger name for which we are doing the booking. What is the amount for that flight? What is the payment mode? And the flight number for which the passenger is doing the booking, and the seats. How many seats the passengers want to reserve for this flight. Now let's go to the Postman. So as we discussed, this is the end URL, right? Localhost 8081 with V1 API bookings, and this is a post request, so we have to use here post parameter. Then come to the body section. Inside the body section, we have to configure this as a raw. And for this raw, we have to choose the data type as JSON. Once this information is done, then we will use this JSON request. So this JSON request is consist of opening and closing bracket along with this 5 parameter as we have discussed. So now we are defining this flight number as EK402 because this is available in our flight system, and the number of seats I want to reserve 1 for this passenger Preet Singhani, and the total amount for this flight is 5000, and the payment mode is debit card. Now let's run this application. If we click on the send button, we can see 201 status, because for any of the post requests we will always get the status message as 201, which means it is created successfully. And if you go here inside the pretty section, you can see the message booking ID created successfully. Now we will verify this information in the logs for the flight booking system and the booking microservices that these logs are available, and then we will go to the SQL database and we will verify accordingly these details. So first let's go to the Visual Studio Code, and here if you see inside the booking request, we are getting this message booking status is booking created and seats are reserved for booking EK402. Similarly, we will go to the flight service, and here we can see the message reserve seats 1 for flight number, and the flight seat details are updated successfully. So I will quickly show you the same message inside the booking service IMPL, and we will be good to go for. So here if in the booking service, if you see, we are having this message seats are reserved for this booking and booking ID created successfully, which we saw in our postman. And for the flight service, if we navigate, flight seat details updated successfully, and also we are seeing reserved seats for flight number. So we are printing how many seats we are reserving, right? As the logs look fine, now let's go back to our SQL database. So inside the SQL database, if you see, previously we have 247 seats and total available seats are 250. So if I execute this one, the seats will reduce to 246. Okay. So let's execute this code, and we can see here the seats has been reduced from 247 to 246, and the same details are available for this flight information. And if we go to the bookings, we can see the new entry has been created for Preet Singhani at booking number 7, and these are the booking information. You can ignore rest of the fields because I was just giving one try, so some entries are still there.
In the next video, we will see the synchronous communication between booking services and payment service. For this thing, we will see the example using web client and HTTP exchange.